Okay. So I have a lot of experience on in this particular CAD/CAM area, and prior to teaching, I also worked in uh, company TCS for 4 years in this particular CAD/CAM area only. So I have enough experience and can teach you this particular subject in the best way possible, and uh, with uh, with the help of my, I can share my prior experiences as well. Okay, whenever get a chance. Now coming to the okay, there are certain prerequisites for this subject, as well as let me talk about the objectives and outcomes. So the prerequisite for this CAD subject is computer aided engineering drawing, which you already completed during your second year first semester. Okay, in a lab form, you already learned about AutoCAD, how to make use of the tool AutoCAD. You created different entities, wireframe entities, and I hope you already also developed 3D models using AutoCAD 3D modeling module. So that knowledge will help you. That's a prerequisite. That knowledge will help you in understanding what I'm talking in this particular subject a lot. Okay, so CAD is a prerequisite. So even diploma students also have joined in second year, so there won't be any problem. Everybody is having sufficient knowledge on basic knowledge on AutoCAD. That would be sufficient enough for you to understand some of the topics that I'm going to teach you in this particular subject. Now coming to the course objectives and course outcomes, there are three objectives and six outcomes. Okay, objectives are something like to let you know what is the use of a computer, how the computer is going to be used in case of design, especially engineering design. We are not going to talk about the manufacturing part of it. This subject is strictly restricted to the design aspects of the overall cycle. So one of the main objectives is to let you know how the computer is going to be useful for you for the design purposes. Okay, and to let you the second objective is to let you understand basic analysis involved behind the development of modeling tool, behind the development of the modeling tools. So and now the third one is similar kind of objective, the development of the analysis tool. So now I'm not talking about the making use of the tool, behind the development of the tool, which means for example, if you are trying to develop a tool, if you're trying to develop a two-dimensional tool like AutoCAD, so during your CAD classes, you are an end user. You actually act as an end user for the AutoCAD, which means you just learn. You hardly learned how to create a circle, how to create a line, how to create different type of objects that are available in the AutoCAD options, icons. As an end user, you learn, but development of AutoCAD is something different. If you want to develop, for example, straight line, you know how to create a straight line, but behind that, what is happening? For example, as an end user, by picking two endpoints, you may be in a position to create a straight line which is visible to you in the AutoCAD screen, but behind that there must be a kind of mathematics, logics. There are many other things. By picking 2 points, how to create, how to display that straight line and all those things, that is actually part of the development of the tool itself. That's the part of the development. So here, the as an end user, you learned AutoCAD, but behind that, what is happening is one of the objective in this particular subject. We are not, we cannot teach each and every, each and every detail of development of entire tool, but very basic level. Being the BTech students, as you are exposed to the development of tools right now, uh, you are at the very basic level. So hardly we touch about that very basic mathematics and transformations, all those things. So not only the 3D modeling tools, but also analysis tools, some mathematics behind the analysis tools. Also, all these three are the main course objectives. Okay, and coming to the outcomes, whether how do we know whether the objectives are met or not, whether uh, the intent object intended objectives are really reached to you or not. How through course outcomes we can understand, we can estimate whether you understood or not. So after the successful completion of the course, you will be in a position to, you will understand the various different types of applications, okay, and uh, computer based applications for modeling as well as analysis, and also you will understand CAD process and also interaction with other tools via neutral file formats. So that is another topic. So how to interact the data from the data which you created in one application, how it can be transferred to another application, which means you created one AutoCAD file, for example, you created, but I want to open that AutoCAD file in some other application. So some neutral file formats are required. So you will understand all those things, and mathematical representation techniques behind 2D curve transformations, all those things you will understand. As I told you, lines, circles, what's the background of that, what is the mathematical representation, all those things you will understand. And similarly, surface entities, so rectangular surface, circular surface, there are varieties of surfaces are available, and some parametric synthetic surfaces are also available, synthetic curves are available. The mathematics behind that you will understand, and you will be tested, okay. And similarly 3D models, some basic 3D models, right? So what is the how the 3D models are being represented, and what are the representation techniques behind it, all those things you will understand. And you will also understand some concepts of analysis tools. So they are the 6 course outcomes, okay. And now the time is almost 9:30, okay. Coming to the syllabus and lesson plan. One minute. Okay. Coming to the syllabus and lesson plan, which is visible to you, right? Is this visible to you? Syllabus and lesson plan. Is this visible to you?
Yes, sir.
Okay, fine. Thank you. So, uh, totally 6 units are there, right? And first unit talks about, of course, apart from the course orientation. In the first unit, some brief introduction about uh, the use of and computer-based applications for design, and various CAD process, CAD tools, geometric modeling techniques, 2D transformations, 3D transformations, concatenated transformations. Transformations are something like, for example, if you look at this picture on the left side, the if you look at the left side picture, there are two pictures here. The left side picture is these are the reference pictures to explain to you about the syllabus content. They will help you understanding the syllabus as well. So if you look at the left side picture, the green color one, there are three pictures within the left side one. So the top one, if you look at that, green color area is there, and pink color area is there. So for example, green color area is you want to move to the green is the old object, and the pink one is the new object. So all these things you already practiced in your AutoCAD. For example, the first one is simply nothing but moving one object from one location to another location. So which is called translation, okay, which is one of the transformation. And similarly, if you look at the second object, the same area is zoomed out, okay, is zoomed out, which means its shape is not distorted, but its area is zoomed out. So which is nothing but scaling. This operation is the technical term for this operation is scaling, scaling up and scaling down. And similarly, if you look at the third picture, the same old green color area, now you actually it is turned, it is rotated. So the rotation is another operation. All these operations you already performed in AutoCAD. So these kind of operations are called as transformations. Okay, the transformations can happen on 2D object as well as on a 3D object. So in the first unit, if you look at the first unit, the 2D transformations. So what is happening behind, how the transformations are happening, what are the mathematics involved to transform the objects, 2D objects or 3D objects in an application. All those things are also part of the first unit. Okay. And now coming to the second unit deals with different types of curve and 2D entities. Okay, 2D entities are again divided into analytical curves as well as synthetic curves. Analytical curves are very simple curves like lines, circles. What do you mean by curve entities? Are two curve entities. If you look at this picture, okay, if you look at this picture, an object can be created using wireframe geometry or surface geometry or solid geometry. Okay, this diagram really helps you in understanding the subsequent units as well. So that's why let me show you this picture. So for example, the same solid, a box, you can say box. A box is represented using wireframe. Okay, which is nothing but all the edges alone are shown of the box. There is nothing inside. There is no area also. It is just with the help of a few straight lines you are actually trying to represent a box. So this is one way of representing the geometry, and very olden technique actually. Okay, very olden technique, almost like 1970s, I think. And, during the period of 1970s or 60s, during that time, the very initial days of development of CAD tools, the people started creating the objects using wireframe entities like this. Okay, and slowly the evolution happened on the CAD tools, and then slowly the people tried to, the scientists and engineers, they could understand how to create a surfaces also, how to capture surface information also for the same solid. So later surface geometry, the CAD tools could also show the surface information. They could include the surface information as well, and through the surface information, probably they could able to calculate the overall surface area of the box, though the internal details are not visible to them. Though they cannot calculate the volume of the box, they could calculate the surface related properties like overall surface area, what is the midpoint of a surface, all such kind of surface related details also they could calculate it slowly, probably during 1970s to 1980s. That was the situation of CAD tools. And since 1980s, there is undoubtedly excellent progress happened on the CAD tools. They could capture the internal details also, which means what is the volume of the box and what is not, apart from the edges, apart from the surfaces, on top of those details, they could also capture the internal details of the solid as well. So all these things are but for the same object, some people are using wireframes, or these are called as 2D curves. All these are things, wireframe geometry, whatever the entities that you are using here in the wireframe geometry, they are all curves. Straight line is one is the kind of curve, whereas if you have a hole within this box, probably the circular hole, maybe on the top it may be represented like a circular arc, sorry, circle. On the bottom also there will be another circle, and joined with two straight lines. So all those things are 2D curves. All those things are called as a curve entities. So in the second unit, you are going to talk about different types of curve entities and mathematics behind the curve entities. And there is something called synthetic curves also. They are also part of the second unit, synthetic curves. But synthetic curves are evolution of analytical curves. Evaluation means, for example, spline curve. We already know about a spline, how to create a spline and all. So simply by picking few points, the spline would be created in AutoCAD, right? So they are all kind of a synthetic curves. So we also talk about mathematics behind the synthetic curves as well in the second unit. Now coming to the third unit, we talk about analytical surfaces, synthetic surfaces, okay, and mathematics behind those things. Similarly, in the um, uh, in the fourth unit we talk about different solid modeling, solid representation, different coming to the solids, there are techniques are very important. So half space boundary representation, CSG, all those techniques we are going to talk about solid representation, okay, solid model, solid representation. So 4 units are completed, and at the end of fourth unit we also talk about neutral file formats, how neutral file formats will help any user to uh, to play with data that you created in one application. You can transfer to another application. Neutral file formats will help you. So, so that's the end of fourth unit. Now coming to the 5 and 6 units, they are totally deal with some FEM topics, finite element method, which is used for analyzing analysis purpose. Okay, I hope you uh, listen the different analysis tools like ANSYS, etc. There are specific analysis tools, okay, ANSYS hypermesh like this. Just like modeling tools, there are specific special modeling tools like Creo. AutoCAD is not a complete modeling tool, but AutoCAD is exclusively meant for 2D purposes. There are exclusive CAD tools for 3D modeling like Creo, CATIA, like this. And similarly, there are certain CAD exclusive CAD tools for analysis purpose as well. So we are going to, all these things are part of CAD. So we last 2 units are dedicated for to understand the mathematics behind analysis tools. Very basic mathematics. If anybody is interested to explore more, to learn more on FEM topics, they can choose elective course on FEM later. Okay. Now coming to the textbooks, I hope you are clear with the syllabus and what are the objectives and outcomes at the end of this particular subject. And coming to the textbooks and web references, there are the textbooks are there mentioned in the PPT, and apart from the textbooks, the web reference is also there. And as online classes is giving a more advantage for us, the materials, whatever the PPTs and other materials that we have, even we sometimes soft copy of the textbooks also I can circulate to you easily through the Teams itself. So the online class is really helping in many ways. Okay. Only thing is your side, how much interest that you gonna pay, that makes how much benefit that you can how much you can benefit it. Okay. So your part is left. Now there are official web references also, like through NPTEL, and there are many books available in online. And apart from that, some of the IITs are providing online material. So I just showed some of the web references, official references. Um, of course, books.google, in that some official books are available. Probably you can search for that. Apart from that, also there are many other websites which you can make use. But always, whenever you are getting some information, whenever you are taking some information, the authority of that information is very important. See, nowadays many people are just like that, uploading many videos. We don't know the background of those people as well. Just for the sake of views, or for the sake of something, they may be saying something without having the proper experience. And so that's the reason. Even if you take any other material on your own, any even YouTube video on your own, you need to check the the um, authority of that particular material. Okay, always better to follow the official information so that there won't be any mismatches. Okay, I hope you are following. And being the course orientation, we also need to talk about some history of CAD CAM. uh, though the subject is confined to CAD alone, but CAM is not CAM can't be left alone. Why? Because CAM is obviously going to the end end user of CAD. Okay, so whatever the information that you created, the files that you created in the CAD, obviously the design is going to be used for ultimately it's going to be used for manufacturing as well. So computer aided design is nothing but CAD, computer aided manufacturing is nothing but CAM. Now, if you look at the history, different phases of development, or the present situation of the CAD CAM has started. It has its roots since 1950s. Okay, so during 1950s, once the cathode ray tube, hope you see some of the old TVs which are still working with based on cathode ray tube, the CRT technique, very old TVs, right? Television. So once the CRT has developed, then only the people started thinking that we can see even the scientists started working on how to develop models on CRT screen. Why? Because the screen is available, I can see that. So how to make use of the screen and how to interact with the screen, all those things started since 1950s. So not only for the modeling purpose, but also parallel to the for the manufacturing. So NC is something related to the manufacturing. So probably you would have already exposed to some of the lathe machines, milling machines, and all those things. And I hope you worked with those machines manually. But NC machine is something like numerical control, which means how to operate that machine using numbers, numerical control, nothing but numerical control. You want to control that machine using some numbers. Those numbers are, of course, are they converted into uh, bytes, and those bytes are uh, uh, you know they punched on a punched tape. So numerical control, they were using punched tapes. They used to feed a punched tape. The punched tape is actually programmed using those dots and all. So that punched tape they used to feed to a machine, lathe machine or milling machine, and that machine used to understand from the punched tape. They used to understand what is it's supposed to do, and it used to perform that operation without any manual operation. So that numerical control also evolved in 1950s parallelly for the manufacturing purpose. So slowly it has evolved 1960s, 1970s, 1980s, 1990s. You know, as I told you before, wireframe modeling techniques have evolved, and then surface modeling tools have evolved. If you look at this 1970s wireframe modeling is there, 1980s integration, solid modeling, all those techniques. Okay, and similarly 1990s data management also there, and then CALS, computer integrated manufacturing, SIM, like that. So many advancements happened, and we no need to talk about what has happened after 2000. It's a huge drastic change. Nowadays even people can operate machine anywhere across the globe. Okay, even at the remotest part of the machine, you can control the machine. Such kind of technology is there. Even everything would be recorded also. Okay, so still there are many points to be discussed. These flow chart and all those things. Being the first class, I spent some time on the interface as well. So we surely continue this class uh, tomorrow, because this particular typical product cycle will take a lot of time. And meanwhile, at the end of this class, I will share this PPT. I will share this PPT for you. So you also can meanwhile go through the PPT, and so that tomorrow you can post your questions. Okay. Now let me. It's the time is almost like 9:45, right? Uh, Now, if you have any queries, probably you can raise your hand if you want to say something, if you want to ask anything. Session is open to you all. Just wait. I'm just taking the attendance. Okay. Am I audible to everybody?
Yes, sir. Yes, sir.
Okay. Someone is saying that uh, we don't have experience with lathe personally. Okay. So far, you're not exposed to lathe machine or milling machines, I think, right? Okay, don't worry. And fine. Many people are responding. It's good. No problem. Uh, of course, those we are not going to talk about those machines and machinery, because computer-aided manufacturing is not part of this particular subject. As an additional, you know, CAD CAM, generally they are not two separated entities. As the reason being said, CAM is actually the end user of the CAD. So computer-aided manufacturing, if time permits, definitely I would like to explain uh, more about CAM as well. Okay, it's really very very interesting topic. But you have another subject. If not in this particular semester, in another semester, you will be taught about various CAM tools and also NC programming. Very very interesting topics are there. And there is a lab also. Okay. uh, of course, CAD CAE lab is there, and apart from that there is another lab where you are going to write NC programs, and you can visually see within the computer screen itself. You can simulate whether the program, how your program is actually going to simulate how it is going to operate a lathe machine or milling machine, like that. You will be exposed to all such kind of things in the subsequent subjects and labs as well. You don't need to worry.